go ahead and look at 29, lesson 29. You kind of see where we're headed. Okay, you sure? Okay. All right. Once you found the 29, put your pencil in there and kind of hold the place, and then look up here and we'll go over the quiz. One note about the tests. Look at Violet's. Some of y'all your parents just kind of give it to you, I know, and that's fine. But just so you know, I've been putting in the email to do it on notebook paper. It's easier to grade on notebook paper than it is on the actual test. It's okay, because I send it to the parents, not to y'all, because I don't have all y'all's email addresses. So, for future ones, if you could just do it on your notebook paper like Violet did, she's the example. Do you want to hold it and stand up? Okay. So, she's got her name up there, she's got the test, and other people did too, but hers is on top. She's got the problems number, and a lot of them, she circled her final answer. That way when I'm looking through, I can tell. I teach some other classes at another place, and I was grading some of their tests, y'all, and I had to like turn them. I was like, what in the world are they doing? Like, I couldn't figure out where they were going, because the stuff was like going everywhere. So, if you'll be like Violet and the others who did this, because some of y'all do this too, and just number it straight down, and then circle your answers, and that'll help me when I'm grading, okay? It's not bad to write on the test form, like, I don't care as long as your parents are fine, but if you do some work on the test and some work on your paper, I have to sit there to grade it and keep flipping back and forth. You see what I'm saying? So it's a lot easier if you'll do it all on the notebook paper. Everybody cool? We got that? All right. I just keep forgetting to tell y'all that in class, and I know that the parent emails don't always get to y'all, and that's cool. Okay, let's look at this first one. To divide fractions, y'all already said you have to multiply by the reciprocal. Yeah, and I'm going to use a dot because I do not like it when they use an X. All right, so times, I'm going to flip this one. That's the reciprocal. Now, can I cancel?
Yes.
Yeah, I can. Now, what if I didn't want to? I could just multiply straight across and I'd get 15/12. But then I'd have to divide the top and the bottom by 3, and I'd get 5/4, right? But what if I cancel? Well, these two have a common factor. What is it?
3.
3, just like I'm divided by 3 here. So how many 3's are in that 3? 1. How many 3's are in this 6? 2. And then I can multiply straight across. 5 times 1 is 5, and 2 times 2 is 4. Either way you do it, you're going to get 5/4 as your answer. If the numbers are really, really big, I find canceling easier than waiting till the end and having to simplify. If you're having trouble with canceling, please let me know, because that's actually something you use in algebra. When they get to the big algebraic fractions, fractions don't go away. They get bigger, okay? And you put variables in them, yes. But if you learn the rules with numbers, then when you get in algebra, you're not going to have trouble with it. Dave? Oh, very good question. David's saying, would this be 1 1/4? And yes, it is. And your book would probably say to go ahead and change it. But really, as far as higher math goes, from like algebra up, they usually have you leave it as this. So I'm used to leaving it as this. But they're both the same, and I would take either answer because they're equivalent. Okay? As long as it's simplified. If you gave me 15/12, I would say, no, you didn't simplify. If you gave me this, I'd say, yes, that's right. And if you gave me this, I'd say, yes, that's right. And it's because of things you're going to do in algebra, this form is actually easier, but you'll get there later, okay? But you're right, it is the same as that. All right, let's look at this one. Can you multiply fractions like this? You don't just do 2 times 3 and 1/3 times 1/2? No. Yeah, you got to change it to an improper. So 2 3's is 6 plus the 1 is 7. I'm just changing 2 1/3 to 7/3. All right, then I've got 3 times 2 is 6 plus 1 is 7. Wait, I messed up, didn't I? No, I didn't. Okay, I thought I messed up because I got the same, almost the same thing. Let me just check. Yes, that's right. Okay, good. Y'all tell me if I messed up with it.
Yes.
Okay, good. All right, and then I see if I can cancel. Now, I don't have to flip this one. How come I'm not going to flip that?
Because it's not a division.
It's not a division. And that's probably the hardest thing about tests or quizzes with these kind of problems. When they're all mixed up, you kind of get used to flipping, and you know, wait a second, this is a multiplication, I'm not flipping anything. So stop and ask yourself, wait, should I flip this or not? And this one you don't. All right, can we cancel? No. So we just multiply straight across. How do I know that I can't cancel? Well, 3 and 7 do not have any common factors. Yeah, they're both prime, aren't they? And then 7 and 2 do not have any common factors. So this one's just 49, 6. And I would take that answer, but like David said earlier, you could also change it to a mixed number. How many wholes if it takes 6? Exactly, 8 and 1 6. Because how many, if I want a whole for this fraction, it'd be 6, 6 would make 1 whole. Well, I have enough to have 8 of them, because 8 times 6 is 48, and I'd have 1 left over. But either of these answers is fine. It's interesting, one more note about that. In algebra, I actually prefer them to leave it this way. But now either way is fine, okay? LCM of 8 and 10. What's the LCM? Least common multiple. So you have to multiply. The M is like, oh wait, that's where I list the multiples. I have to multiply. So I usually, this is just my way of doing it. I'll usually look at the biggest number and I'll think multiples. 10. Will 8 go into 10? No, so that's not it. 20? No. 30? No. 40? Yes, because 8 times 5 is 40. So that's my first common multiple. It's not, well, least common multiple, what would be less than that? That's a common multiple. You see what I'm saying? That's all right, let me list the 8s out. 8, 16, 24, 32, 40. That's the least common. They have to both have it. Does that make sense? So it's the smallest number that they both have in common. Okay? All right, then I'm going to keep going with my 10. So 50. Will 8 go into 50? Not evenly, right? Let's see, 60. What about 8 into 60? No. What about 70? No. What about 80? Yes. 8 times 10 is 80. So they wanted 2, oh, it just says 1 LCM, didn't it? Oh, I'm so sorry. I was reading like it was 2. Sorry. That's why I just go keep going. Y'all want to keep going and find the next one? No, not really. So this is enough right here. Okay, that's enough. All right. Average of these two. We just barely touched on that last week, and you probably only got a little bit of homework over that. How do you average? Raise your hand if you can remind me. How do you average? All right, I got 3. 3, maybe 4. All right, Josiah, how do you average?
You would add the numbers and divide by 2.
Very good. Why divide by 2? Is it always 2?
No, it depends on how many numbers you have.
Okay, so you add the numbers up, so we're going to add those and we get 110. And Josiah said, I count the numbers that I have, there are 2 of them, and I'm going to divide that by 2. Okay? When you divide 110 by 2, it's 55. So the average, we can abbreviate it as AVG, is 55. Okay? All right, this one, how many of y'all drew the box diagram like you did a couple lessons ago? Okay, good. That's, David, you did it a different way?
I forgot to draw the box.
Oh, it's okay, because it didn't say you had to.
Yeah.
So that's okay. But did you do it mathematically then? You did it? Okay, that's fine, and that's good. All right, but I drew my box this way so I could use the lines on my notebook paper when I did it. I need how many boxes? 8. I don't know if I can do this evenly, but we'll see. There's half again, there's half again. Let's see if I have 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 of them, 3 boxes that is, are what? Girls. These are the girls. That means, what about from here on down? Those are the boys. The whole box is 32. I've divided it into 8 pieces. What is 32 divided by 8? 4. So that means each box represents 4. So they didn't ask me how many girls there were, so I didn't even have to find that out. They just asked me how many boys there were. So I've got how many boxes of boys? 5. So 5 fours is 20. David, I want to know how you did it. Now you don't have to know David's way, but I'm curious how you did it.
I haven't forgotten, but I think I just did 8 divided by 32, which was 1, and then
4.
management.
Something times something.
Good. So it sounds like you didn't divide by 8 because 8 was on the bottom. So you were finding 1/8 of 32, and 1/8.
It's 4, so 4 times 3.
Good. So if 1/8 is 4, we want 3 of them, which would be 12, and that's the number of girls, right? Then did you subtract to find the number of boys? Very good. So you take that away. Oh wait, I did the wrong number.
Yeah.
It's supposed to be 32, isn't it? And then take away the number of girls, which you said was 12. And we got the same answer. So it's 2 different ways to do it. I really like, when I first learned this box diagram, I've always done it this way, the way David said, or similar to that. But when I learned this box diagram, when my boys were doing this, and I was like, oh, that's a cool way to do it. And I actually use that a lot, because it's a very visual way of doing it. All right, who tackled the bonus? Anybody tackle this? Violet's like, yeah. Kristen, yeah. All right, Christian, tell me the first step, just the first step.
The parentheses.
Okay, good.
1, 2, 1, half, to the square, so.
All right, good. So, did you change it to an improper first?
Yeah, so I changed it to an improper fraction of 3/2.
Very good. So 3/2 is the same as 1 1/2. And then we're gonna need to square it. So somebody else, good job, Christian. I want somebody else to take the next step. All right, David.
You change the division thing to a
All right, you do in just a minute, but we've got to square this first. There you go. So start with this part.
So it's 3 halves times 3 halves.
Good.
It's 9.
Very good. 9/4. And it's really like you're squaring the top and the bottom, right? Or you're thinking 3 halves times 3 halves. Either way you think of it is fine. All right, so 9/4 divided by 7 1/2. I'm gonna erase the 7 1/2. What are we gonna need to change it to? An improper fraction. All right, one of the girls, what's this as an improper fraction? Very good, Raina. 7 times 2 is 14, plus 1 is 15. So 15/2. All right, I still have a division. Raise your hand if you can tell me now what I need to do. All right, I already got y'all. I need somebody different. We're gonna stretch it out across. Flip the thingy, Lily says. 9/4. Then you're gonna change this to times, right? And then we're gonna flip this. Good. All right. Who is brave enough to cancel for us? Josiah. Come on, you can do it.
4 and 2 cancel.
Good. How many 2s are in 2?
1,
1. And what I put here?
2,
2. What about here and here?
9,
They will. That's all right. You guys see it?
Oh, yeah.
If you did it, it's okay as long as you said fast.
3.
3. Okay, how many 3s are in here? 3. How many 3s are in here? 5. Go straight across. 3 times 1, which is 3. 2 times 5, which is 10. If you just multiplied straight across, it would have been 18 over 60. And then if you had divided by, what, 6? You would have still gotten 3/10. So if the canceling you're struggling with, you can still do it that way, but I really want to encourage you, work on the canceling, because it's going to help you later. It's really going to help you later with some algebraic stuff, okay? All right. I'm going to erase this. While I'm erasing, Benjamin told me a joke the other day. You ready? What do you call a bear with no teeth?
13.
No. Come on, think about it. Might make you hungry if you think about it.
Toothless bear.
No. Think about the candy aisle.
Berry?
A gummy bear.
Oh.
Oh.
Oh, is that gone?
I guess that's not a dad joke, that's a little kid joke, but I thought it was cute. Anyway. All right, lesson 29, we are going to do, I just want to read it in the book. This is one of those that I think we can just look at it and y'all not have to write it down. Y'all like things that we look at and don't write down, right? All right, so look at that lesson 29, page 188. Josiah, you got it, Dave's got it. Good, 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 good. Oh, can you let Raina look on you? Slide it over there. Because it is a pretty good picture that we don't want to have to draw. Okay, I want to skip down to the example 1. It says use a number line to round 283 to the nearest 100. Okay, I think y'all know how to round that without using a number line. Would you agree? But let's look at what the concept they're wanting us to grab from looking at a number line. So look down at the solution. They drew a number line and they put 283 between what two numbers? 200 and 300. Yeah, y'all just say it. 200 and 300. Is it closer to 200 or closer to 300? 300. So since it's telling us to round to the nearest 100, and it's closer to 300 than 200, we know it would be 300. Now, did we have to draw a number line to do that? No, we could have done that without drawing a number line, but that's part of the lesson they're wanting us to see. All right, don't turn the page. It says round 283 to the nearest 10. Don't turn the page. What's in the tens? What number is in the tens place? Okay, 8. Okay? If they want us to round to the tens place, then we have to look at which number to tell us how to round.
The times.
Not the tens. The one that's after it. Yes, so we gotta look at the ones. So if we're rounding to the tens, we look at the number after it. If that number is below 5, then we're gonna drop it off and leave this number, right? If that number is 5 or above, then we drop it off and change this to the higher number, right? So since they want it to the tens, what's this 3 gonna tell me? Tells me it's not enough to round up, so I'm just gonna drop it off, and it should be 280. Now turn the page and let's look at the number line that they came up with.
I told the page
Or is it across from it?
Yeah, it's like right across.
Oh, sorry, mine was on another, but that's okay, because I have a mistake over here, and I have one out of order. All right, so look at the number line across from it. They put 283 between 280 and 290, and it's obvious it would be closer to 280 than to 290, right? So this is just a visual way of doing what you've already been doing. I think everybody in here has been rounding things. All right, the next example, they just do the same thing, but without drawing the number line. Okay, so let's look at this example. I do want you to write this one. This one is lesson 29, example 3. So we're going to put lesson 29 at the top of your paper and example 3, in case you want to look back at it. Round 5,280. So there is one non-zero digit. Okay, I want to talk about this one because it's not that it's that hard, it's just the way they word it. It's kind of confusing.
Okay.
Round 5,280 so that there is one non-zero digit. Okay? Now, right now, there are 3 non-zero digits. Right? 5 is not 0, 2 is not 0, 8 is not 0, but 0 is 0. Okay? I see some of y'all still copying, so I'm going to wait just a second.
Are you ready?
Yeah, you're right now. I feel like this needs to be there because we need to talk about it. And too, if we just talk and never write, it'll tune it out. So we gotta write something. Okay. So what's a non-zero digit?
Anything except for 0?
Anything except for 0. Okay? So here we have 1, 2, 3. I'm gonna underline them. 1, 2, 3 non-zero digits. And then we have a 0. They want us to round it so there's only one non-zero digit. So which one are we going to keep? Yeah, the 5. You can't say that 5,280 is about 8 or is about 80, right? So what they're meaning is round, drop everything off except for the top, the first one. So if they want me to keep one non-zero digit, it's going to be the 5. So I look behind it. Is the 2 going to round that 5 up or keep it a 5?
Keep it at 5.
Keep it at 5, and what happens to the rest of the numbers?
Zeros.
They're all zeros. So let's reread the directions and see if we did what they said. Round so that there is one non-zero digit. There's our non-zero digit. Okay? Does that make sense?
Yes.
I looked at that and I just thought it was a little bit confusing. Okay? All right, look in your book at example 4. I don't feel like we need to write this one. 93,167,000. Which number is in the millions place? One of those numbers is in the millions place. Which one is it?
The 3.
The 3. So if that's the number they want us to round, we have to look, raise your hand on this, but don't yell it out, because I want to see that we're all together. 93 million, they want us to round to the 1 million, okay, which is where the 3 is. Raise your hand if you can tell me the number that we're looking at to decide what to round. You see what I'm saying? We've got to round that 3. Raise your hand if you can tell me which of those other numbers tell me whether to round or not. All right, I got 2. Look down at your book, guys. Try to figure it out. Violet, you want to take a stab at it? All right, what's the number after the 3?
The 1.
The 1. So we're always looking at the number after where they want us to rank, okay? So in this example, 93,167,000, they want us to round to the 1 million's place, which is the 3. So we'll look right over after it and we see a 1, okay? 1 tells us to do what? Down, yeah, drop everything off. So that'll be 93 million and we drop everything off. Does that make sense? Okay. All right, let's look at, let's write example 5. Example 5 says to round 14 7/12 to the nearest whole number. Okay? 14 7/12 to the nearest whole number. Well, when we count, raise your hand if you can tell me what 2 whole numbers this is going to be in between. Don't yell it out. What 2 whole numbers is this number going to be in between? Let them finish writing. I see y'all's hand. Let them finish writing. I need 2. Is it going to be between 2 and 3? Is it between 20 and 21? What 2 numbers is this going to be between? Everybody write what 2 numbers you think it's between. Everybody write. I'm going to start down here because they're writing. And by the time I get down that way, I want to see what you think. What's it between?
Oh, wait.
That's true. Get 2 consecutive numbers. But that is true. So like 2 and 3, 4 and 5. Give me 2 consecutive numbers. It's actually back it up. Not between those 2, it's between the 4. Did you write it?
Oh.
No, that's okay. Yes, good. Yes. The girls have got it, they're just quiet. Okay? All right, so if you're counting all the way up to you get to 14, this is past 14, but not as high as 15. So it's between 14 and 15. Okay? Now let's think. Is it closer to 14 or is it closer to 15? Anybody? 15. Why?
Because the
Yeah.
7 over 12.
Yes, 7/12 is more than halfway to the next number, right? Halfway in 12ths would be what number up here? If I was going to do half, yeah, if I was going to do 1/2, but I wanted it in 12ths, I would have to multiply that by 6, and that would be 6/12 is the same as 1/2, okay? This is 7/12, so it's past halfway, so it's going to be closer. So put 2 little squiggly lines and put 15. You would round that as to almost to 15. Now, what are the squiggly lines? What do they mean? You don't know?
Fractions rounding up the
No. Watch this. 1/2 is equal to 2/4. Do you agree?
Yes.
I use that because I know they're equal. I use this when it's approximate. two little squiggly lines. It's like an equal, but it's not, okay? So you just say approximately. So when you round, your book may not do that, but you will later. So we'll just go ahead and toss it out there now, okay? All right, mentally estimating. Okay, let's do example 6. Yep. Mentally estimating, I'm going to do the first one because it tends to be fractions are the ones that most people are worried about here. Okay? 5 7/10 times 3 1/3. But it says to estimate. What does that mean?
It means to make guess.
Yeah, it's kind of an educated guess. Now, it's mentally a guess, but it's not like, oh, it's about 100, like a random guess. We're not talking about a random guess. This is an educated guess. So what you would do is you would round each one of those. 5, well, we haven't done it yet. What's 5 7/10? Is that closer to 5 or closer to 6? 6. So I'm going to say that's about 6. And 3 1/3, is it closer to 3 or closer to 4?
3.
Closer to 3.
So
this is approximately 18. Now let me tell you why this is useful. Because some of you may be thinking, well, I mean, how's that helpful? At least it's easier, right? If you're doing a fraction problem, especially those division problems, and you're still a little shaky about it, you can estimate it and know about what the answer should be. I can look at this and go, well, that's about 6, and that's about 3. 6 times 3 is 18. Now, if I actually do the problem out and I get 4,000, is that about 18? No. Did you hear what I said? What if I do this problem out and I get the answer of 4,000? Well, I know the answer should be about 18, so I did something wrong, okay? So estimating first is a good thing. This is a really important thing to learn how to do. And then you can read the others. When you do it at home, it's just rounding and doing the problem in a simpler way. Christian?
When we were doing I just forgot my question.
That's okay. Is it about this?
Yeah, it'll come back.
That's okay. I'm gonna leave that there and we'll come up here. If it comes back, we'll go back to it. How about that? All right, lesson 30. Okay, so you might want to write down lesson 30 in your notebook. All right, y'all are chatty. All right, common denominators. I know that y'all have had common denominators before, but what we're going to do is we're going to firm this up to make sure that we know how to do it simply. So this is example 1. I'm going to give you 2 fractions, 2/3 and 1/4, okay? I want them not added, subtracted, or anything like that. I want you to write them with a common denominator. Can you write these? Don't add, don't subtract, or anything. I want these 2 fractions written so that they both have the same denominator. Okay? Just try it first, and then we'll talk about it. What is the common denominator?
12.
12. Now, you remember earlier when we did the least common multiple?
Yes.
The LCD, or the least common denominator, is just the least common multiple of the denominator. It's the same thing. You're trying to figure out the smallest number that both of those are factors of. And if I listed out my multiples of 4, 8, 12, okay, 3 won't go into 4, it won't go into 8, but it will go into 12. So I put 12 down for both of them. Now, I can't just change it to 12, right? I can't just be like, okay, boom, you got 12. What do? No? You're about to ask.
My brain's not working.
Your brain's not working. Okay, that's okay. David, what do I do to make that become 12?
So those, let's say for the 2/3,
Okay.
you see how many times 3 goes into 12, which is 6.
Or how do you get that?
Which that would be 4.
Very
Then
good.
you do 2 times 4, which that would be
Good. So David's saying if I had to do 3 times 4 to get this 12, that's how I know I've got to do times 4 up here, and that gives me 8. Okay? All right. So how about Raina? Help me with this one. We know we want to make it 12. What should I do to 4 to make it become 12?
multiply by 3.
Very good. So if I have to multiply that by 3 to get 12, what am I going to have to multiply this by? By 3. The rule is I got to do the same thing top to bottom, so I get a 3 here. So let me ask you this trick question. Look, which one's bigger, 2/3 or 8/12?
That's equal.
They're the same. Which one's bigger, 1/4 or 3/12? They're equal. Yeah. So they just look different. It's kind of like 2/3 is the name, birth name, and 8/12 is a nickname. It's the same fraction. Okay. Once you get them in a common denominator, then you're able to add them. Okay. Now, why do we even do common denominators? Do y'all know this? Why do we even do this? Why is this a thing?
Maybe because
So you can add the numbers together.
Okay. Why can't we add them if we don't?
Because if you, let's say if you add 2/3 and 1/4, it wouldn't be what was.
Yeah. Let's draw this for just a second.
So it'd be easier for you to.
All right, y'all know I'm not good at drawing fractions, but you know, I can do that symbol, I guess. All right, here's fourths. If I'm gonna add 2/3 plus 1/4, they aren't the same thing. Think about that. I can add 1/3 plus 1/3, that gives me 2/3, right? I can add another third, that gives me 3/3. I can keep adding thirds, 4/3, 5/3, 6/3, 7/3. But you can't add a third and a fourth. 1/3 plus 1/4 is not the same as a 2/3 or 2/4, right? Think about it like this. If you say I have one apple and I got another apple, now I have, what, 2 apples. If I have one banana and another banana, how many bananas do I have? 2 bananas. What happens if I have one apple and one banana? What do I have? One apple banana? It's still just one apple and one banana, like Josiah said. So that's why we have to get common denominators in fractions. You're adding thirds and fourths, and you can't add 2 different things. You know, remember the old problems in 1st grade where they're like, you get 4 cats, and then you get 3 more cats, and you get 12 more cats. How many cats do you have? They used to drive my son crazy. I would see him sitting over there, and he'd be staring out, you know, angry. Y'all know angry. I'd be staring out the window. Like, what is it, hon? I said, we need to think about math. He says, I am thinking about math. And I'm like, well, what are you thinking about? And he says, who would want that many cats? I'm like, no, just do the problem. I don't know. And I'm like, why does that bother you? He's like, well, you have to name them all. And how in the world could you get that many? And I'm like, just do it.
He's like, this is not.
Right. So how does that relate to this? It didn't, but I got your attention, didn't it? All right, so when you add up all those cats, you can do that. But what if you say she got 12 cats and she got 3 dogs? How many does she have total? Well, you don't have dog cats, right? You have to say so many animals or whatever. It's the same thing with fractions, okay? You can't add things that aren't the same. All right, Christian, may I erase this or do you remember your question?
I still do not know my question.
That's okay. If you think of it later, we will get it. All right, everybody stand up. Stretch a little bit. Don't hit the camera. And then if you're close enough to be like touching the person next to you, you need to scoot, okay? Scoot a little bit. Don't move your neighbor, okay? But you scoot a bit. Example 2. I want you to compare these 2 fractions. Example 2, you gotta write it down. Write it down. Compare these 2 fractions. What do I mean when I say compare? What am I wanting you to put in there?
A sign.
A greater than, a less than, or an equal to. That's what I want in between those 2. But you're gonna have to do something to be able to compare them. We just said you can't add apples and bananas. You can't compare apples and bananas, okay? You've got to express them as the same thing. So how would we figure this out?
Make the denominators same.
Yes, make the denominators the same. Raise your hand if you can tell me the common denominator between 6 and 9. I got 1, I got 2, looking for, oh good, I got 3. Keep thinking good, there's 4.
Oh.
Keep,
Yeah,
you haven't figured it out yet, keep thinking. Good. Common denominator between 6 and 9. Go for it, Eli. No? Okay, so that's okay. Violet, go for it. 3 will go into both of them, but I want something I can make them both become. So you're thinking factor, that's okay. So now we want to think multiples of these. So let's take 9. Will 6 go into 9? No. Let's think of the other multiples of 9. I've got 9. 1 times 9 is 9. 2 times 9 is 18. Could I make 6 become 18?
Yes.
Yes. So there's my common denominator, or my least common multiple. All right, now this is where I say, what do I have to do to make it that? I can't just change it. What do I do to 6 to make it become 18?
You have to multiply it by 6.
Not 6.
Or 3,
3,
sorry.
there you go, that's okay. Times 3 on the top, so we get what here? 15 18ths. What do I multiply this by?
2.
2, so multiply by 2 there, and I get 14. Look, would you have thought that those were that close? Look, this is 15 18ths, this is 14 18ths. Now it's obvious that this one's greater than the other. And most of the time when I give students this problem, they just guess. They just guess. They're like, I mean, it looks like this one's bigger, I don't know. But when I give you this problem, like on the quiz next week, I want to see the common denominators. So how I know that you know what you're doing, okay? All right, the rest of this lesson, you're going to be adding and subtracting, all of that. I feel like
Is the
we should try.
Are
Do
the
it.
next lessons going to be like all fractions?
No, not all. They're going to mix it up because they want you to keep. Are you okay, Dad? Okay.
It's like,
They want you to, Christian, they want you to practice this and kind of spiral. You know how SAxon does. So it's not going to be all fractions. All right, everybody write this one down. 3/4 plus 3/8. 3/4 plus 3/8. I think y'all could do that. Go for it. On your paper. 3/4 plus 3/8. Hey guys, this might be a good time to mention that if there ends up being a lot of chatter, I'll do an assigned seat. So, I mean, there are times that it's appropriate, but just heads up. We could do boy, girl, boy, girl, boy, girl, boy, girl. Y'all gonna make the girls mad because they're not chatting now. Just so you know. All right, look at the denominator. Some of you are still working, that's okay, finish it here. Look at the denominators. I usually look at the biggest one and say, can I make this number become that number? Sometimes I can't. Like here, I couldn't make 6 become 9. Okay, if you can't, you can't. But for this one, you can. So let's make them both 8. Now, don't erase if you didn't use 8. Okay, this one's already 3/8. This one I would have to multiply by 2 and I'd get 6/8. Then I add them together and I get 9/8, which is 1 and 1, 8. Some of y'all, I noticed, did 16ths. And that would be totally fine. Look what happens if you do 16ths. This one would have to be multiplied by 4, so I'd have to multiply that one by 4. This one would have to be multiplied by 2, so I'd multiply that one by 2. And I'd get 18/16, which is 1 and 2/16, which is 1 and 1/8. So even if you chose a different denominator, as long as you do the work with it, it'll still work out. Did anybody else choose a different denominator other than 8 or 16? You tried different one? I thought I saw you use a bigger one.
Yeah.
You did? Did it work?
I didn't finish it.
You didn't quite finish it? Okay. But they'll all simplify to the same answer. Christian.
I almost did, but then I just wanted to make it easier on myself, so I just.
Okay, so then you did it. That's okay. All right, I'm gonna do example 4, and then some of y'all didn't get a chance to finish that one all the way out. I'm gonna wait a little longer and make sure you get a chance to finish. Because this one's done the same way. What is the difference though? There's one thing different about this problem. What is it?
Multiplication.
No,
I mean, subtraction.
it's subtraction. So try this one. It's done the same way. Getting the common denominator.
We just, so we.
Alright, so go on to the next step.
Just fine.
Plus 6, so did you Good. Alright, what's your last step? So they wanted you to subtract the this, so now that you know that this is the same as this, and this is the same as this, just subtract it. Very good, so put a minus here, and put an equals right here, and circle that final equal. Where did you use all your brain cells? On the right over, it's construction, took it all away, I know.
What he was doing, he was
What?
doing the
No,
math
see,
with
see,
the construction.
I had that.
You did
I had
Like
that.
he was doing like the
Christian was there, that's how he knows. Was he having fun with you while he was on the?
no, I was just,
Look.
I came and then like his vibe just fell on me.
You did. Alright, good. Alright, so it looks like most everybody went with a 12. So I'm gonna do it up here. Alright, Eli, you're gonna help me. Yep.
I can do this problem.
I know you can, I know you can. It's okay. How do you get from 6 to 12? What do you have to do to this?
2.
Good, see, he knows. Times 2, so what goes here?
15.
No, 2, sorry, it's my handwriting. 2 5s.
10.
10. Alright, then I'm gonna multiply this by what to get this?
3.
Good. So what's this?
9.
10 twelfths minus 9 twelfths, 1 12. There's your answer. Okay? Got it. Okay? So these are going to get bigger and longer and all sorts of things like that, but they're all common denominators done the same way. Anybody want to ask about anything before I move on?
I'm still trying to remember my question.
That's all right. And you know, late tonight you'll be laying in bed and go, there it is. Then you can ask your mom, can I do all this? Yeah. No, you're fine. All right, turn in your book to page 202. This is like one of my favorite things to do. Do y'all like to graph? Have y'all graphed before? 202. Yes, it's an investigation. I love graphing. Sorry, why are you shaking your hand? Do you not like graphing? It's I don't know. We'll see. He's just. All right, here's your coordinate plane. Okay, it's basically like you take a number line that we're used to working with, and we take another number line at a 90-degree angle. These are perpendicular lines. And not only do we have our regular number line going this way, and our negatives here, we also have a number line going up and down. I'm going to do that in a different color. So this is going to be like -1, -2, -3. This is going to be +1, +2, +3, like that. This is called your which axis? Anybody remember?
Yeah.
What is it?
Is it X and
X, and this one is
Y?
Y. Okay. When they give you, you know, like if you go into somebody's house or going somewhere, you have to have directions, right, to get there. Well, the directions to the point are going to be an ordered pair given to you like this. The X is always first, the Y is always second. If you forget that, think of this. They're alphabetical order. X, Y. X, Y, Z, right? So if you forget which one comes first, alphabetical order. So your x-axis is your first number. For example, if I tell you to find the point 0, 0, does anybody know where that is? David? Right in the middle. That's 0, 0. What if I wanted you to find the point 1, 2? Raise your hand if you can help me find 1, 2. 1, 2. Are you Christian?
So it's 1, the Y.
Yeah, we always start at 0, 0, which has a special name. What's that? Origin. Okay, so we always start at the origin. It's kind of like you always start your directions from your house. Okay, that's where we start, the origin. And we're going to go right to 1, but we're not going to put a point because we have to go up 2. And that's where the point goes. Okay? Now, let's look at the ones in the book. Because mine is not super neat on the board. I'll have to get me a nice one to put up there, okay? All right, look at the one in the book on page 202. You see the graph? A little neater. You're going to need some graph paper when we do these. Turn the page, look at 203. Is it across from it? I brought y'all some graph paper because I forgot to let you know. Oh, you have some, don't you, Dave? Do you have some? Okay. Do you have some? There you go. You need some? I meant to tell y'all that we would need it and then I forgot. So I just brought you some, okay? Look at this page. We need to talk some vocabulary. There are quadrants. The root word quad, what does it mean? 4. What do you see there? There are 4 of them. 4 quadrants. There's 4 little squares. There's 4 little areas. So look right here. Quadrant 1, 2, 3, 4. That's the name of the numbers of quadrant. That could be on a test or a quiz real soon. Just, hey, number them. It's not 1, 2, 3, 4. It's 1 here. I think because this is primarily the quadrant that we work in is where all the positives. Everything's positive, both numbers. Because you go the right and then up to get to this quadrant. So quadrant 1, 2, 3, 4. And you can look at that in your book. Look down at example 1. We're not going to write it. It's all right here, but I am going to ask you to help me find these points. Okay? Look at point A and put your pencil on the origin. Take your pencil and put it on the origin of this graph. Okay? One of you, yeah, you're sharing a book. Put your pencil on the origin. Good. Bless you. Bless your heart. Put it, wait, the origin. Put it on the origin, which is 0, 0. Good. All right. From the origin, are you going to have to go right or left to get to A?
Right.
Right. How many? 4. Should be 4. Bless you. So you have to go to the right 4, and then how much do you have to go up? 3. So what's the ordered pair for point A? 4, 3. Because we have to go to the right 4, up 3. All right, everybody, let's look at B. The answer's down there for us, right? Look at B. Do we go left or do we go right? Left. How many? 3. So that's going to be -3. And how far do we go up? 4. So -3, 4. Look at C. See, it's a little tricky. Left or right? Left, how many?
5.
5, so -5, do we go up or down?
No.
We don't. So it's a 0 there, so -5, 0. All right, don't turn the page. We're gonna keep doing them, but I don't want you to look. Do they give you the other answers? I don't think they give you the other. Oh, then you don't have to worry about not turning the page. Okay, we're gonna do the rest of it. And I'm gonna go call on you and ask you. So if you're unsure, listen to your friends, your peers in here and see. And if you have a question, I'll help you. What happens if you get it wrong? Y'all have learned that by now, right? Nothing's gonna happen. All right, everybody find D. You don't know who I'm gonna call on. Find D. And I want you to give me the ordered pair. So everybody jot it down now on your paper. Just doesn't matter where, write a little D. And write down what you think the ordered pair is. And then I'm gonna call on somebody to help me with it. All right, raise your hand if you feel confident about D. All right, Josiah, what'd you put?
-4 and then comma -3.
Very well done, Josiah. -4, -3. You had to go to the left 4, and then you had to go down 3. Good job. Everybody find E. Write down what you think the order pair for E is. This one could be a little tricky. Anybody brave enough they want to do this one? All right, David had it up first. David?
0 and -5.
Why is it 0 first? You're right.
Because, you go to the left or to the right.
Yeah, the first number is left or right, and with this one, you don't go left or right. You just go straight down. So it's 0 and then -5. All right, everybody do F. So 5 minutes. You're not free to fight yet. All my students say they love that song because they know what that means. Okay. Violet, tell me what you think F is.
3, then minus.
Very good. 3, -4. Do y'all agree with her? I said very good, so that should be right, right? Okay. What about G? This one's tricky, but y'all seem to be getting it. Raise your hand if you feel good about G. I gotta get one of the girls. Violet just did one. All right, Lily or Raina, who's gonna do G?
5, 0.
Very good, 5, 0. Because you go to the right 5 and you don't go up or down. Good job. All right, I want to look at the next lesson. The rest of this is plotting points, and you're going to need some graph paper. I just gifted you a piece, okay? That will at least get you started for a little bit. Be sure and follow the directions. If you don't follow the directions, you may not quite get the picture that you want. All right, stop. We're not done. Nope, not till the next one. Look at page 207. I want you to skip 9 unless you just want to do it. It's optional.
Which one?
Number 9 on page 207. Because it would take a good bit of time. Now it's cool if you have the time to do it. It's making your own picture and listing the ordered pairs that it would take for somebody else to draw that picture, which is really kind of cool. All right, I still have just a couple of minutes. I want to look at the last lesson. Okay, don't pack up. Get your notebook out.
lesson?
I'm going to wait on you.
The last lesson? Or,
Yeah, there's one more lesson that we're doing this week.
no, but you were talking
The last problem, yeah, that's
about.
optional. Yes, but I still want to look at the last lesson after that. Now, the last lesson is about decimals. So Christian asked earlier, hey, are we going to do fractions the whole time? And no, you're not, okay? Everybody write down. When I say these words, you write down the picture you get in your head. You ready? Everybody ready? 7/10. Write down what you think of when I say 7/10. if you're brave, some of y'all are brave, all of y'all are brave, you just don't talk as much, that's okay. What'd you write down for 7/10? Alright, Josiah? 7/10. How many people wrote this like Josiah? Okay, so about half. What else, if you didn't write 7/10, what did you write? Christian? Alright, 0.7, or 0.7, I'll stick a placeholder in here. Are these the same? Yes. So, in this lesson, they're just wanting you to see that you can write these numbers as a fraction or a decimal, okay? It's also going to give you some place value, and make sure you know how to read it. Here's the most common problem I see. When people say, when they say this number, I'm going to say it wrong first. A lot of people say 123 and 4/10, or they'll say 123.4. Okay, I get what they're saying. But technically, when are you supposed to say and? At the decimal. So you wouldn't say 123, you would say 123 and 4/10. Okay? That's the main thing in this lesson, one of the main things. Here's the other. When I give you a decimal like this, and I tell you, hey, change that to a fraction, don't stress out, you just read it. That's 7/10. We know what that is. If I give you this one, you just say 81 what?
81 over 100.
Yeah, 81 hundredths is 81 over 100. Now you may have to simplify them, but it's pretty easy to go from a decimal to a fraction. A little bit harder to go from a fraction to a decimal. But that's as far as that lesson will go this week. Christian, do you remember?
No, but
No. Did I write it
you
wrong?
can't, no, but you're saying you can simplify it. You can't simplify
You
it.
might be able to simplify. Oh, decimals. I mean when you change it from a decimal to a fraction. Thank you for asking that. You may get a fraction that can be simplified, and then you'll have to do that.
Yeah,
Okay?
but you can't ever change it.
No. So what I'm meaning is, if you get something like this, what is that decimal? Yeah, but however you did.
Oh, 16.
Yes, there you go. Now, that can be simplified. That would be what? 3/5. So if they ask you for the fraction for this, you need to go all the way here. That's what I'm thinking. Yeah, good question. Thank you for clarifying that. Everybody good? So this week, if there's a test, I can't remember if there is. There's not one? Okay, the next time you do a test, you're gonna write it on what?
No.
Paper and be like that, okay? Or whoever else did. All right, y'all have a good week.
That's not the same.
Yes, go ahead and send it. Well, you don't have to, I can write it today, and then I'll leave if you need to.
Well, if you don't understand, like,
Yes, that'll be good.
Your gear on it.
Still going. Oh wow, it's a whole hour. I don't know. Ask her.
Miss Hill,
Yes.
should we stop this video?
I don't know, do y'all know how to start it again? Is it just the button?
Yeah, it's just a normal video.
Okay, then